Good morning, Algebra 2 Honor Trick students. So this one, it's for sections 4.3 of Trigonometry. So it's vertical translations and phase shift. So last time, 4.1, 4.2, we talked about the basic form and the parent graph of sine and cosine. And now today we'll talk about the standard form, the alternate form, and also the ultimate form. So you'll see that in a minute. So standard form is always given as y equals sine of x minus h plus k. And then y equals cosine of x minus h plus k. So where h is considered the horizontal phase shift. Okay, so h, so that's just the horizontal shift. And then k, which is the vertical translation. Or the vertical shift. Depends on which way that you prefer to call this. And now let's start it off with the first two problem. So another thing I want to talk about here, it's the one cycle. So since we do know that the parent graph of sine, it's a roller coaster from 0 to 2 pi. So anytime they try to do the one cycle test for sine and cosine, it's always bounded from 0 to 2 pi. Well, because based off the parent graph. So for sine and cosine. Okay, so now let's take a look at this. So first thing that you want to do, identifying the amplitude. So the amplitude, so this one can be written as y equals 2 sine of 4x. So basically you can swap those terms. So A is 2, absolute value of 2, so amplitude is 2. And then the value of B is 4. So that means the period is 2 pi over 4, which is pi over 2. And then there's no horizontal shift here, so h is 0. And then k, which is negative 2. Alright? So now, another thing that you might be considered doing, it's the one cycle test, but this one is pretty straightforward. So this one, there's no phase shift. So there's no need to do the one cycle test. So what we can do, so we set up the x-axis, the y-axis. Okay, so let's put in the x-axis and the y-axis. So we just need one cycles of the function. So started off with 0 all the way to the end of the period, which is pi over 2. So now right here you need to customize the scale. So we do know that the amplitude is 2, so 1, 2, negative 1, negative 2, down the bottom. So half of the distance, so this one it's pi over 4. Now another thing you probably want to watch out, because this one it's with the vertical translation. So this one is going to be shifted 2 unit down. So what you need to do, you probably want to customize the scale a little bit more here. So this one is all the way down to negative 4. Okay, so I'll open up to the new slide for this one here. Okay, so let me just snip this one so I can just give you more space. Okay, let's try to do this. Okay, so open up the new slide. So again, it's very important for you to customize the scale with all the corresponding position. Without doing that, your graph is going to be either, well, it's either out of space, or it's going to be out of bound, or it's not good enough space for you to sketch the graph. Okay, so you've got to be very careful. So once again, the value of A, so it's 2, and the period, 2 pi over 4, which is pi over 2. And then there's no h, so that means h is 0, so k is negative 2. So again, I need the x-axis and the y-axis. Okay, so for the y-axis, you can just make it a little bit over all the way to the left. Okay, let me just undo this one here. Okay, so from 0 all the way to pi over 2, and then half of the distance, pi over 4. So this one is 1, 2, 3, 4. And down here, -1, -2, -3, -4. And for those you might be wondering, why do I need to go all the way down to -4? Well, because the vertical translation. You'll see that in a minute. And then half of the distance between 0 and pi over 4, then that'll be pi over 8. And right here, 3 pi over 8. So we do know that sine is just a roller coaster. So it's a roller coaster curve. So without the vertical translation, so the graph started at 0. Okay, so without making the vertical translation, so it started at 0 first. So just want to sketch the parent graph. And then amplitude, so then that's 2. And then back to 0, back to -2, and then back to 0. So if this one is just the parent graph, so that means it's a dotted curve. Okay, so it's dotted. And now with the vertical translation, so it's 2 unit down, so that means we need to shift all those positions 2 unit down. Okay, so let's use different color for this one. So -2, so 0 minus 2, -2. And 2 minus 2, 0. And 0 minus 2, -2. Again, so all the way 2 unit down. So -2 minus 2, -4. And then 0 minus 2, -2. And the blue curve, then that'll be the final graph of this function. Again, we just need one cycle. That's it. Okay, so now going back to the template. And the other one, so we do have y equals cosine of x minus pi over 4. So again, find out that the amplitude, so which is what, 1. The value b, well, if the number is not given, it's also 1. And then the period, 2 pi over b, so 2 pi over 1, which is 2 pi. And then this one, it shows that it's a horizontal phase shift. So it's pi over 4 unit to the right. Okay, so pi over 4 unit to the right. Okay, so again, so this one, let me just put into the new position here, to the new space. So y equals cosine of x minus pi over 4. Okay, so just that. So once we identify all those elements, and then all you can do, sketch the graph. Another thing you might be considered doing, the one cycle test. And for those you might be wondering, how do I put in the one cycle test? And what's the best thing about doing the one cycle test? So this one, it goes all the way from 0 to 2 pi, because that is a cosine curve. So whatever the quantity that you have inside the parentheses, you always want to put it right in between the boundary. So we can find out the initial positions and the final positions. Well, the way to solve for this is just like going back to algebra 1, compound inequality. So add pi over 4, all sides. So 2 pi plus pi over 4, which is, well, this one is 8 pi over 4, so it's 9 pi over 4. So the good thing about doing this, not only we can take care of the period with the one cycle of the graph, but also we can find out the initial position. Okay, excuse me. Let me just... And then the final position. Okay, so for the one cycle. So now, to look at that. And again, we need the x-axis and the y-axis. So this one, there's no vertical translation. So that's the good thing. Okay, so started off, well, this one is 0, y-axis, the x-axis. But this time, instead of starting at 0, we started at pi over 4. Okay, so pi over 4 unit to the right. And it ends at 9 pi over 4. So again, I'm just making the scale for the x-axis and the y-axis. And the amplitude for this one is just normal 1. Okay, so half of the distance between pi over 4 and 9 pi over 4, then that'll be, well, combine them together, so 10 pi over 4 divided by 2, then that'll be 10 pi over 8. Okay, so 10 pi over 8, reduce it, 5 pi over 4. And then half of the distance here, so 6 pi over 4 divided by 2, so 6 pi over 8, which is 3 pi over 4. And then over here, half of the distance right in between. So just keep adding. So simply keep adding that 2 pi over 4. Then that'd be 7 pi over 4. And we do know that this one is just a cosine curve. So that means it's a bell curve. So at pi over 4, we started at 1. And then the next one, 3 pi over 4, 0. And then 5 pi over 4 all the way down to negative 1. Again, we just need to put in the parent graph into the new period. And the 7 pi over 4 going back to 0. And then 9 pi over 4 goes all the way back up to 1. Okay, so just 1 cycle of the cosine curve. And here's what we got. Okay. Again, the 1 cycle test, that's pretty powerful because that can take care of the period, the horizontal phase shift, and also it tells you the initial and the final position. Okay, so now let's go back to the template. See what else that we have. So they're all considered the standard form. And now, what about for the one that is considered the alternate form, or the alternative forms? So if C is any real number, and B is greater than 0, and then the graph of y equals sine of the quantity bx plus c, and y equals cosine of the quantity bx plus c, we have the following property. So the period is still the same as what we found, so 2 pi over b. But the thing is that the phase shift this time here, it's not given explicitly. So what we need to do, we need to factor out the b. So the way to find out the phase shift, it's negative c over b. And for those you might be wondering why it's like that. Because by the time that you take out the b, so we're using it as the greatest common factor. So sine of b times the quantity of x, and then plus c over b. And compare that to back to the standard form. So back to the standard form, it's given us sine of x minus h plus k. So this one here, so b is just 1. So b right here, that's just 1. And then for h, compare and contrast, it's negative c over b. And then for cosine, it's basically the same thing. So take out b right there, the greatest common factor. And then whatever that's remains, so we just want to rewrite it. So c over b. Okay, so now for the following, so identifying the amplitude, period, the phase shift, then sketch 1 cycle, 1 complete cycles of the curve. Okay, so one thing that you might be considered doing, so identifying the value of a, b, and c. And then the period, and then the phase shift. So a is 3. And then for b right here, so that's pi. So that means the value of c right here, it's negative, well, it's positive, because that's negative, negative. So this one, it's negative pi over 2. Okay, got to be very careful. Okay, so negative, so it matches up with the negative. So negative times negative, so then that'll be what? Positive. And now what else do we need to find out? The value of the period. So 2 pi over pi. Then that'll be 2. And then the phase shift. So the phase shift would be negative c over b. So negative, negative. So that turns out to be positive. Pi over 2 divided by b divided by pi. So that means the horizontal phase shift would be considered 1/2. Okay, so here's what we found. And the one cycle test. You want to do the one cycle test. So this one, it goes all the way from 0 to 2 pi. And the quantity that I need to put in here in the middle, so then that'll be pi x minus pi over 2. And then you want to solve for x. So solve for x at pi over 2 all each sides. So this one here, so pi over 2 less than or equal to pi x less than or equal to 2 pi plus pi over 2. So this one, pi over 2, so 2 pi, which is 4 pi over 2 plus pi over 2, 5 pi over 2. And then divided by pi, so we do have 1/2. It's less than x, it's less than pi over, 5 over 2. The pi got canceled here. Okay, so now we need the x-axis and the y-axis. So just one cycle. So this time there's no need to sketch the parent functions, because that the period, it's already being taken care of, and also the initial positions, final positions, they're already found. So it's 1/2, 5/2, and then half of the distance. So 1/2 plus 5/2, 6 over 2, so 3 divided by 2, 3/2. And this one here is 2 over 2, which is 1. And then plus another 1/2, then that'll be what? 2. Okay, so from 1/2 to 5/2, and then the amplitude, so it's 1, 2, 3. So 1, 2, 3. Down here, -1, -2, -3. And we do know that this one is a bell curve, because that's cosine. So for those you might be wondering, how do I get the bell curve roller coaster? It's about the parent graph that I did for the previous video, 4.1 and 4.2. Okay, so it started at 1/2. So at 1/2, so it goes all the way at 3, because that's the bell curve, the maximum first. And then the next position, it goes all the way back down to 0. 3/2 goes all the way down to the min, -3. And then at 2, back to 0. And then 5/2, all the way up to 3 again. And then simply just connect the dots. It's a bell curve. So there's no vertical translation, so there's no need to shift the points up and down. So the next one is quite similar, but that one involved with the reflections. There's a negative sign change right there. So let me rewrite it on the next slide here. So negative sine of 2x minus pi over 2. So y equals negative sine of 2x minus pi over 2. Okay, so identifying the amplitude. So the amplitude, it's just absolute value of -1, so which is 1. And then the value of b, then that's 2. And the value of c, it's negative pi over 2. And then the period, so it's 2 pi over 2, which is pi. And then the phase shift, which is negative c over b. So negative pi over 2, positive pi over 2, divided by 2. So it's pi over 4. And also you can do the one cycle. Now this time you got to be very careful with the reflections. So the reflections, we'll deal with that once we sketch the parent functions of sine of this quantity. So one cycle test. So this one, it goes all the way from 0 to 2 pi. And then the quantity, we want to put in 2x minus pi over 2. So add pi over 2, so we got pi over 2 less than or equal to 2x, less than or equal to 5 pi over 2, because 2 pi is written as 4 pi over 2, plus pi over 2, 5 pi over 2, not 5 pi over 4. And then divided by 2, so we got pi over 4, it's less than or equal to x, it's less than or equal to 5 pi over 4. Okay, so again, I need the x-axis and the y-axis. Okay, so label those axes, the origin. So pi over 4, 5 pi over 4. So again, right between that, the initial position and the final position, you want to make 4 intervals, 4 equal intervals. So half of the distance. So 6 pi over 4 divided by 2, 6 pi over 8. Again, the way that I did it, so basically just put in the midpoint formula. Pi over 4 plus 5 pi over 4 divided by 2. So 6 pi over 4 divided by 2. So 6 pi over 8. And then reduce. 3 pi over 4. And then right here, half of the distance. So pi over 4, 3 pi over 4, 4 pi over 4, which is pi divided by 2. Pi over 2. And then over here, 8 pi over 4, 2 pi divided by 2. Then that'll be pi. And now, the amplitude. So the amplitude is 1. Now we're got to be very careful with this. So let's start it with the parent function first, the parent graph. So without the reflection, if that's a sine, so we started at 0. And then the next one, it's all the way up to 1, because that's a roller coaster. And then the next position is 0. Down here, -1. And then over here, 0. Again, it's a sine curve, but this one is just the parent graph without the reflection. Okay, let me just write down reflection here as well. So the negative sign, it shows that it's reflected over the x-axis. So this one is just the parent function, so just dot it. And now reflected, so that's 0, so there's no such thing positive, negative, so this one just remains the same as 0. And then up 1 here, so it's reflected over the x-axis. So this one, it goes all the way back down to -1. 0 remains the same. -1 goes all the way back up to the top at 1. And then this one remains 0. And then this one is the final graph. So that's why it's a solid curve. Just like that. Okay, so now let's see what else. So we did that, alternate form. And what about the ultimate form? So ultimate form of sine and cosine. So this one is given with that y equals k plus a times sine of capital B. As you can see that b right here, this one is being factored in. So sine of capital B times the quantity of x minus h. And then for the cosine, similar. So y equals k plus a cosine of capital B times the quantity of x minus h. So where b, it's greater than 0. Again, amplitude, same as what we did. Absolute value of a. Period, 2 pi over b. The phase shift, this one is given explicitly. Okay? And then vertical translation, that's just the value of k. So grab 1 complete cycles of each of the following functions. So y equals -1 plus sine of 2x plus pi. So this one looks like it's written in the ultimate form, but it thinks that the 2. So this one is called the non-factor form. So what we need to do, we want to take out that 2 first. So this one is written as -1 plus sine of 2 times the quantity of x plus pi over 2. And also this one can be written as sine of 2 times x plus pi over 2. So for those 2 terms, the vertical translation and sine of the whole quantity, you can swap them around. -1. So identifying the value, all the elements, so the value of a, obviously it's 1. Absolute value of 1, so then that's 1. And then the value of b, that's 2. So the period, 2 pi over 2, which is pi. And then the phase shift, so the phase shift for this one, it's negative pi over 2. So negative pi over 2, so shifted pi over 2 unit to the left. And then the value of k, the vertical translation, -1. Again, you can do the 1 cycle test. So anytime that thing's getting kind of complicated with the quantity, the one after that sine and cosine, you always want to do the one cycle test, because it's a whole lot easier by the time we sketch the graph. The one cycle test, the outcome, what does that tell you? It gives you the initial position, the final position. It takes care of the period, the phase shift, all that. So it's like one thing that can take care of 4 different items. Okay, so now from 0 to 2 pi for the one cycle test. And then this one's 2x plus pi. We want to put it right here. And then solve for x, subtract pi each side. So we got negative pi less than or equal to 2x less than or equal to pi. And then divided by 2. So that means negative pi over 2 is less than or equal to x. It's less than or equal to pi over 2. Okay, so this one, just one cycle with the vertical translation. So let's just make the graph here. Okay, so from negative pi over 2 all the way to pi over 2. Midpoint, 0. And then split it into half right here. So negative pi over 4, positive pi over 4. And let's start it off with the parent function, the parent graph, without the vertical translation. So amplitude for this one is 1. Okay. Let me just move that 0. Okay, so negative 1, negative 2. So started out with the parent graph. So this one, it's a sine curve. So started at negative pi over 2 because that's the initial position. So that would be 0. Next position, then that'd be 1. And then over here, 0, negative 1, and then 0. Again, it's just the parent graph, dotted. It's a roller coaster. And now, with the vertical translation, so the vertical translation is negative 1. So that means everything we need to move 1 unit down. So instead of being here at 0, so this one is negative 1. Okay, once again, I need to use different color. So down here, negative 1. And then 1 minus 1, 0. 0 minus 1, negative 1. And then right here, negative 1 minus 1, negative 2. And then 0 minus 1, negative 1. Simply connect them. And that would be the final graph. And now, what about the one with the fractions? So this one might be a little bit tedious. Well, we'll take a look at that. So 2/3 minus 4/3, cosine of 3x minus pi. Okay, let me just snip this one here. It happens like that all the time. So let's see one more time. Okay, so and it looks like this one is going to be way a lot more complicated, but let's find out. So again, the 3 right here, we can put it out. So it looks like this one is already written in terms of the ultimate form, but the thing is that the non-factor form. So we need to pull out that 3 in order to make that as the ultimate form. So y equals negative 4/3, and also swap the terms. Cosine of 3 times x minus pi over 3. And then plus 2/3. So the value of A, absolute value of negative 4/3, so 4/3. The value of B, that's 3, period, 2 pi over 3. Fraction, another fraction. And then H, pi over 3, pi over 3 unit shifted to the right. And then the value of K, 2/3. And what else does that involve? The reflection. Wow, that's a lot of stuff right here. It's a reflection over the x-axis. Because the negative sign, it's sitting outside the whole function here. Okay, so now let's see what we can do. One cycle test. from 0 to 2 pi. And then this one we just want to put in the whole quantity, 3x minus pi. I mean, you can put in that 3 times the quantity of x minus pi over 3. You can do it either way. Eventually, you'll get the same result for the initial position and the final position. 3x minus pi, gotta be careful, I almost make the error. Because I want to put in the original quantity. So 3x minus pi. So add pi first. So pi, it's less than or equal to 3x. It's less than or equal to 3 pi. So simply just add pi for each term. And then divided by 3. So we got pi over 3. It's less than or equal to x. It's less than or equal to pi. And now I need the x-axis, the y-axis. Got to be careful with the scale that you're making here. So the scale, so started at pi over 3. And then this one ends at pi. So half of the distance right in between, so this one would be, well, pi is like 3 pi over 3. So 4 pi over 3 divided by 2, 4 pi over 6, which is 2 pi over 3. And then right here, half of the distance, pi over 3 plus 2 pi over 3, 3 pi over 3, which is pi, divided by 2, pi over 2. And then right here, 5 pi over 3, combine them, divided by 2, 5 pi over 6. And the amplitude, so the amplitude is 4/3, but the things that don't forget, with the 2/3 of the vertical translation. So this one I would like to set up as 2/3 for each margin. So 2/3, 4/3, and then over here, negative 2/3, positive, well, negative as well, negative 4/3. And now let's just start it with the graph without the vertical translation and without the reflection. Okay, so without the vertical translation and the reflections, so the parent graph looks like this. It's a cosine curve. So absolute value of negative 4/3, that's 4/3. So start it right here at pi over 3, 4/3. And then back down to 0. And then this one here, the midpoint, all the way down to negative 4/3. Again, I'm just making a graph without the vertical translation and the reflection. And then the next positions, back to 0. And then all the way up here, back to 4/3. So that's a parent graph, so that means it's just dotted. It's not solid. And then the next thing that you want to do. Now for those you might be wondering, does that matter which one that I do next? The reflections and the vertical translation. It doesn't matter. You can do either one of those first. So 2/3. So this one, the graph is going to be shifted up 2/3. So up 2/3, so I need to add 2/3 here. So this one would be what, 6 over 3, which is 2. So all the position, you want to add 2/3. So the next one is still considered dotted because that we're going to finish the reflections after this. Add 2/3, so it's all the way up here. And then this position, add 2/3, so it goes all the way up to 2/3. Down here, add 2/3, then that'd be negative 2/3. Every position, add 2/3. This one up here, 2/3. Okay, so dotted. And then finally, we're going to deal with the reflections. So this one is the reflections over the x-axis. So whatever the point that we have up here, so we need to reflect it down to the bottom. So this one I need to extend that a little bit further. So it's all the way down to negative 6 over 3, which is negative 2. Okay, so that's pink. So this position right here. So negative 6 over 3. So for this final position, so instead of being 2, so it's all the way down to negative 2. And then this one here, instead of being 2/3, so it goes all the way back down to negative 2/3. And then down here on the bottom, well, this one, instead of being negative 2/3, so this one is all the way back up to 2/3. And then over here, back down to negative 2/3. And then positive 2, all the way back down to negative 2. So here we go, the final graph. It's just like a normal bell curve. Okay, so that's it. Okay, so now let's see what else that we have. Back to the template. I think there's another problem, another example. Well, here's the one that you guys can try. So for those who might be wondering, well, is this the restricted interval? It is. So once you do the one cycle test, so you need to extend the graph all the way from negative 5 pi over 6 to 7 pi over 6. So again, if you want to find out the element, okay, so let's say that A is what, 3, and then B, well, here's 2. So period, 2 pi over 2. And then for the value of H, well, this one is not that obvious, so you need to take out that 2 first. So it's pi over 6. So for the value of H, pi over 6. K, it's nothing. Okay, so again, run through the one cycle test and then try to sketch the graph of the parent functions. And once you sketch one cycle, and then the rest of that, you can extend it with the continuation. Alright? So let me know any questions that you have, any comments on my YouTube channel. So I'll see you guys next time. Thank you for watching this video today. Take care, guys.